Now let's see a new scheduling algorithm called as longest job first scheduling algorithm. Okay, it is exactly opposite to shortest job first scheduling algorithm, which means in shortest job first scheduling algorithm we were taking the process with the least burst time, right? Now in case of longest job first scheduling algorithm, among all arrived processes, process with the largest burst time will be scheduled first. Okay, that is what we mean by longest job first scheduling algorithm, and it is a non-preemptive scheduling algorithm. Okay, it is a non-preemptive scheduling algorithm. Also, it is a priority based algorithm, right? Why it's a priority based algorithm? Because we are going to give higher priority to processes with the largest burst time comparing to processes with the shortest burst time, which means the process with the largest burst time will be executed first. Okay, so it is clearly a priority based scheduling algorithm. Now, that is, of course, in case if it is a priority based scheduling algorithm, definitely we will have a starvation problem, right? Why starvation problem? Because processes with the shorter burst times will starve, which means the processes with the shorter burst time will wait indefinitely to get the CPU, right? See, we have a CPU, we have RAM, and we have hard disk. Okay, for example, now let us assume there is a process named as P1, its execution time is 20 nanosecond. There is a process named P2, its execution is 2 nanoseconds. Now, since P1 has the largest burst time, P1 will be scheduled first. Now, what might happen is there is a process named process P2. Process P2 is in ready state, which means its execution time is 2 nanoseconds. Okay, now there is a chance for process P3 whose execution time is greater than 2 nanoseconds to arrive before P1's completion, right? In that case, P3 will be scheduled, making P2 to wait. Now again, after some time there might come a process. Now as of now, P3 is executing, and after some time, before the completion of process P3, there might occur a process P4 which might come to the RAM, okay, whose execution time is greater than 2 nanoseconds. In that case, again after completion of P3, P4 will be scheduled, making P2 to wait, and this can keep on happening. And as we know, the number of processes are infinite, and so processes might keep on moving to the RAM, thus making process P2 to wait indefinitely, or thus making process P2 to starve. Okay, this is what we mean by starvation problem. In simple, I can say that any priority, we have already seen that any priority based scheduling algorithm will suffer from the problem of starvation, and longest job for scheduling algorithm is also a priority based scheduling algorithm because we give higher priority to process with the largest burst time. Okay, fine. Now, so these are the disadvantages. Okay, one of the disadvantages, starvation problem exists. There is also other disadvantages like convoy effect problem. See, what is meant by convoy effect problem? A smaller process is waiting for a larger process to release the CPU. This problem will definitely happen in largest job for scheduling algorithm because we always pick the largest process first, right? See, in case if we have three processes, say in here, let us assume this example. Okay, there is a process named as, now we will be actually taking process P1, right? Because P1 has the highest priority. Now definitely process P2 might have to wait till P1's completion, right? Now this 220 nanosecond may be even much more bigger, like 2000 nanoseconds. In that case, this smaller process might have to wait for the bigger process to release the CPU. This is what we mean by convoy effect problem, and definitely convoy effect problem can exist in case of longest job for scheduling algorithm. Fine. Now throughput is very less. Why throughput is very less? See, when will throughput be high? Let us assume we are taking this much time. Okay, within this time we are seeing how many processes have been completed. Okay, within this time we are checking how many processes are getting completed. Now, in case if we have taken shorter jobs, in that case, let us assume this we have completed a process over here, and we have completed a process over here, we are completing a process over here. Since we are taking shorter processes, we are able to complete lot of processes, 1 2 3 4 5, and then we are actually doing it. Now in case if you would have taken larger processes, what might have happened is we could complete a process over here, we might not even be able to complete the second process, right here. Let us assume the second process is getting completed over here. Okay, Now the throughput at this point of time is just 1, whereas here the throughput at this point of time is more than 5, right? Why this has happened? Because we are taking shorter processes first, whereas here we are taking longer processes, okay? So this is the reason. See, again we assume that, as always, the number of processes which are being created in our computer is infinite, okay? So here, since we are taking shorter processes, the throughput is higher, whereas here, since we are preferring longer processes comparing to shorter processes, our throughput is less, okay? Fine. So it is very obvious, right? Throughput is very less in case of longest job for scheduling algorithm, and practically very difficult to implement. Why? Exactly the same reason for what we have seen for SJF, right? SJF really depends on the burst time. Again, longest job for scheduling algorithm also depends on the burst time, which means the process which is having the higher burst time should be scheduled first, right? Now, before executing a process, it is very difficult to predict the burst time, right? That is what we have seen. So definitely, even longest job for scheduling algorithm will also suffer from this disadvantage, okay? Fine. So these four are the disadvantages of longest job for scheduling algorithm. See, generally I don't think we practically use longest job for scheduling algorithm, but it is just to know that there is an algorithm like this, okay? We'll see some problems. Fine.